Now let's see if you. Now last time in our last video we gave this assignment, and I promised you the solution. So let's see if you actually got it when we solved. Now we said our solution starts from diagram, drawing our diagram and getting it right. So y is 60 kilometers away from x on a bearing of 135 degrees. Z is also 80 kilometers away from x on a bearing of 225 degrees. Find I, the distance of z from y, and I, bearing of z from y. Now let's start by noticing which of the points we have to represent first. Y is 60 kilometers away from x. Now, if you check very well, all of the points are taking their root from x, which means x starts first. But while you draw your x, note, where does 135, what's the direction of 135? Downward, south, east, Abi? Then 225 is southwest. So definitely our x is going to be somewhere at the middle at this point. So our point x is going to be somewhere at the middle here. So here is north of x, Abi. Now, y is 135, bearing of 135 from x. So this is x. So bearing of 135 will be somewhere around this region, which is southeast, right? So we draw a line from here down, representing our x. And remember, remember just representing our y line. And remember that the kilometer is what? 60 kilometers, right? So we have 60 kilometers here. And around this line, somewhere around this line, we have our point y, right? So this is our point y now. So here is y. Now z on the other side is also taken from x, and he said it is 225 degrees from x. 225, we said, is on the southwest. So southwest should be somewhere around this region. And don't forget, it is 80 kilometers, and 80 kilometers is bigger than 60 kilometers. So this line obviously has to be longer. So we have 80 kilometers here. Now, somewhere around this line, we'll have our z. So this position z. Now, you have to join z and y together. So this is my line yz. Join them together. So we now form a triangle. Might not actually be right angle triangle, but it is a triangle. So here, from here to here, is how many degrees, class? 135 degrees. And then from here down to this place is how many degrees? 225 degrees. So obviously, we can know this place. Since we know the whole of this as 225, and we know from here to here as 135, we can actually know this place. So this angle here would be 225 minus 125. And that will give us what? 90 degrees. So this place is 90 degrees. So which means one of the angles of the triangle out of the three is now known. Now what do they want us to find? They said we should find the distance of z from y. Distance of z from y is this yz, which is obviously this place, small x. Are we together? Small x. Okay, so if we are to find that small x, thank God we have the angle opposite, so which means we can use either Pythagoras theorem or we can use cosine formula. Do you know why I said we can use Pythagoras theorem? Because this is obviously a right angle triangle. A right angle triangle is a triangle in which one of the sides is 90 degrees. So since you know that one of the sides of this one is 90 degrees, which means you can use Pythagoras theorem. So obviously you can. So if you want to use Pythagoras theorem, this is obviously the hypotenuse because that's longer. So we can as well say that x squared, that's we are working on I now, right? X squared is equal to y squared plus what? Plus z squared. Are we good? Which will give us x squared is equal to, what is y? Let's say 80 squared plus what? 60 squared. Hence, x squared is equal to 6,400, thank you, plus 3,600. So x squared is equal to, add up the two, 10,000. So x squared is equal to square root of 10,000, which will give us, x is equal to, yes, sorry, remove the square here. So x will give us 100 kilometers. So obviously this line is longer, and then its value has to also be bigger. Are we together? All right. So now we have been able to solve this first. Now let us focus on the second. Bearing of z from y. First of all, you need to understand where is the bearing of x from y. Where? In this diagram, which part is the bearing of x from y? Now, this is x. Sorry, bearing of z from y, Abi. Now, this is z. This is y. So bearing of z from y, it means you are starting at y to know where the line from z entered into y. So definitely it's going to be from the north of y down to the line joining z and y. So the whole of this place is the bearing of z from y. Now we can't know that place, but we know the whole of this place from here down to north is 360 degrees, Abi? 360. Now, if we know the angle here, let's name it 5, for example. Are we together? And we know the angle, let's remove this place. And we know the angle here inside this triangle. Let's name it theta. If you know these two angles, it's just simply add up these two, subtract it from 360 degrees. So when you subtract these two angles from 360 degrees, the remaining one becomes the bearing of z from y. Okay, so the question now is, first of all, let's go for phi. All right. What is the angle phi? The bearing of z from y obviously would be equal to 360 degrees, Abi, minus phi plus theta. So if we add this angle phi and this angle theta together and subtract it from 360, the remaining one becomes our bearing. Okay, so we are left to find what the value of phi is. Now, how do we get the value of phi? Class, I told you before now, please listen. I told you before now that from here to here is what? 135 degrees. Now, there is a part in this y that is alternate to that angle. Now, alternate to that angle is from here, which is from this 180 degrees, this south, down to the line of x. So from here to here, it's also the same thing as 135 degrees. Why? Because it is alternate. If from this place to this place is 135 degrees, it means to get this place now is just subtract 135 degrees from 180 degrees. So which is what we did. Phi is 180 degrees minus 135 degrees, and that gives us 45 degrees. So we've gotten our phi, not quite difficult to get. Now, since this is a right angle triangle, it will be very easy for us to use the trig ratio. So we actually decided if you use every other trig ratio, so long as you know the three sides, you can still arrive at the answer. You get? So, but we decided to use sine theta. So sine theta is opposite over hypotenuse. Opposite, this is how I drew this. This is why I drew this. So this diagram is just like a right angle triangle, where this angle here is this angle here. This angle here is this 90 degrees here. And here is our 100 kilometers that we have calculated before. This place is our 80 kilometers. Opposite the angle given. So if you take it, sine is opposite over hypotenuse, which means 80 over hypotenuse is 100. So we have 80 over 100. So we cancel out, and that gives us 4 over 5. And then sine theta is 4 over 5, which is theta is equal to sine inverse of 0.8, because 4 over 5 is 0.8. So you have theta as 53.1. And then, of course, it's going to be 53.1, which is our bearing now. It will be 45, which you already found before, plus 53.1. So if you add it up together, that gives us 98.6. Subtract it from 360, that gives us 261.9 degrees. And then approximately that is 262 degrees. So I have to make sure that you got exactly what you did. So score yourself, and then let's see if you got it right. In our next video, we'll still be talking about more of the type of question that can come out of this, okay? All right, so check our next video.